Hey everyone, just in case you missed class, we're going to do a little recap of the practice problems we did to help you through your async work if you need it. So we'll do solving for a missing side using trig ratios, solving for a missing angle, and then we'll take a look at an application problem as well. So, what did I just do? Okay, so you always want to kind of follow the same steps when you're solving a trig problem. So the first thing you want to do is take a look at your triangle and figure out which sides are we dealing with. So I can see right here that I've got a 71-degree angle, okay? And then look at what sides we're dealing with. I have the hypotenuse, that's always the long side across from the right angle. And then I have the adjacent side. I know it's adjacent because it's right next to the angle I care about, that 71-degree angle, okay? We don't care about the opposite side over here. We're not really using it, so I don't care. So now I got to think through SohCahToa. I got to think which one of these trig ratios relates the adjacent side to the hypotenuse. We can see that adjacent to hypotenuse is cosine. So now we set up our equation, and this is really important. You want to set it up the same way every time. Write it out. Cosine of the angle equals the adjacent side divided by the hypotenuse. Then we can plug stuff in. So our angle, this theta, is 71 degrees. The adjacent side is 4. And our hypotenuse is unknown. It's x. All right, now we can go ahead and solve this. So I've got an x on the bottom, which is a little tricky, but we just want to basically move it over. So I'm going to multiply by x, which will cancel this out. And now we don't have the problem anymore. Now we got x times cosine of 71 degrees. Remember that cosine of 71 degrees is just some number. So I'm going to divide that number to get x alone. So my answer is going to be whatever 4 divided by the cosine of 71 degrees is. So you have a couple options for calculators. I'm going to use Desmos here since we haven't seen that yet. Cool. You just have to be really careful because when you're dealing with trigonometry, there's two different settings your calculators have. You have a radians and a degree setting. So since I'm using degrees, right, our angle's 71 degrees, then I'm going to make sure that Desmos is in degree mode right here. Okay, cool. And then I can go ahead and calculate this. And I get my answer, 12.286. And again, you always want to double check that cosine of 71 is operating in degree mode. If I switch to radians, you can see I get an answer that's wrong. And this time, it's obvious that I have a wrong answer because it's a negative. And I know the side of that triangle can't be a negative number. But it's not always going to be obvious, right? Sometimes you can get tricked and not even notice. I forgot the answer, 12.286. All right, so the side of that triangle is about 12. Now, not all of your diagrams are going to be drawn to scale, but for the most part, you can use the diagram to help you make sense of your answer, right? I'm looking at this. If I would have gotten an answer like x equals 0.5, I know that's wrong because my hypotenuse has to be longer than 4, and about 3 times longer looks about right. Cool. So I'm going to set this one up, but not go ahead and solve it. Just to give you one more example. So I've got this angle right here. And again, first thing first, we label the sides of our triangle. So our hypotenuse is over here, and it looks like we don't need it this time. And then the adjacent side is the one next to the angle we're looking at. The opposite side is the one across from the angle we're looking at. So if I want to relate opposite to adjacent, I need tangent. All right, again, looking back to SohCahToa there. So tangent of an angle is equal to the opposite side divided by the adjacent side. Let me scooch over here. All right, so now we plug in. The angle is 59 degrees. The opposite side is x. The adjacent side is 14. And now I'll go ahead and solve this. We multiply times 14. So our answer is whatever 14 times tangent of 59 degrees is. And again, you do want to show these steps every time. I have a lot of students who are trying to maybe skip through this and just kind of multiply, and you're making a lot of mistakes when you do that. So take the time to write it out, take the time to show your algebra, show your logic, and we'll get our answer. Let me pull up Desmos again. So this time we're doing 14 times tangent of 59. 14 times tangent of 59 degrees. Again, I'm going to double check that I'm in degree mode. Okay, 23.299. I'm just going to round up 23.3. Where's my board? There it is. All right, does that length make sense based on my picture? Looks like this leg is longer than that leg. Seems reasonable. All right, let's try another one. This time we're going to be solving for a missing angle. So it's going to change just a little bit. This time we're going to need to use an inverse trig function. So we want to set this up the same way. The first two steps are exactly the same. So we want to think about what sides are we dealing with. We've got a hypotenuse over here, right? It's across from our 90-degree angle. And then I have my adjacent side. So if I want to relate adjacent to hypotenuse, I use cosine. So cosine of an angle is equal to the adjacent divided by the hypotenuse. Again, referring back to SohCahToa helps me remember that. Okie dokie. So this time I can't plug in the angle because I don't know the angle. But I do know the adjacent side is 6.2, hypotenuse is 9.6. Okay, so for this problem, we need to do an inverse cosine. Okay, so for every function, we have an opposite function. We have an inverse function that'll undo it. So in trig, we have these inverse functions. They look like this, cosine to the -1. Sometimes you'll see them written as arc cosine or arc sine. That means the same thing, but we're going to stick to this notation because that's what our calculator says. So I'm going to take the inverse cosine of both sides. So it's operation that we can do. If we long as we do it to both sides of the equation, we maintain equality. The reason I'm doing that is because the inverse cosine of a cosine cancels each other out. We just have theta left. All right, now I need to throw this into a calculator. So I'm going to show you how to do this in Desmos. So we can just type in when we want cosine of something, but to do inverse cosine, we need to use a little keypad thingy. If we go over to functions, let me hide my face here. Click on functions, and then the first option is the trig stuff, and you'll see right away we've got inverse cosine. Okay, so now I need to put in 6.2 over 9.6. 2. And we get 49.77. Okay, 49.8. I'm going to go ahead and round that. Especially when we're dealing with angles, rounding to the nearest tenth is as close as we ever need to be. Don't have to get super exact with angles. A tenth is usually good enough. Okay, now I'm going to look back at my triangle and see, does that make sense? Does a 49, 50-degree angle look good? And I think so. All right, these legs are almost the same length, not quite. We know they'd be the same length if it was a 45-degree angle. So I'm feeling good about this answer. All right, we'll look at one more like this. We'll just get the setup done. Maybe we'll probably do the whole thing. All right, so again, we want to label our sides. I've got a hypotenuse, 14, and I've got an opposite of 7. Opposite because it's across from the angle that we're looking at. So to relate opposite to hypotenuse, we need so. So that's sine opposite over hypotenuse. All right, so sine of some angle we don't know is equal to 7 over 14. Hold up. I've just noticed something. This is exactly 1/2, 7 out of 14. I think this is one of our special triangles. So I already know what this angle is. It's really helpful to know these two special triangles, and we talked about this a little bit in class. The 45, 45, 90 triangle, where we have two 45-degree angles. We have the two legs are always the exact same length, and the hypotenuse is that length times the square root of 2, and that's always true. We also have something called a 30, 60, 90 triangle, where our two angles are 30 and 60, and 90 obviously. And we see that we have the short leg is exactly half the hypotenuse, so we can take the short leg and double it to get the hypotenuse. And then the long leg, we take the short leg and multiply by the square root of 3. So I know this by heart. I know my 30, 60, 90 triangle. It's something we use a lot in trigonometry, so it's something I've committed to memory. So when I look at this triangle, I already know that the angle is 30 degrees. But real quick, let's go ahead and verify that. So I need to do inverse sine of 7 over 14, or 1/2, to get my angle. I didn't show this step properly, like I did before. And what just happened? Okay. Before I did this really formally, I showed taking the inverse of both sides, but often you'll see me do this little shortcut like that, and that's not a big deal if you do that. But let's go ahead and check their answer real quick. We had inverse sine. So again, we want to go to the keypad, go to functions, inverse sine of 7 over 14. And we get exactly 30 degrees, right? So 7 over 14, it's the same ratio as 1/2. All right, let's do one quick application problem. And that's this. So I cut off the words here, but basically we're asking, what's the distance from the bottom of the Ferris wheel to this aquarium? Okay, so what is this x distance? So we know we have a right triangle. We know this angle right here is 58 degrees. And we know the height of the triangle is 135 meters. So although we're dealing with an application question, we should be able to solve this the same way. The problem is we don't actually have an angle inside of our triangle yet. We know that this angle is 58 degrees, but it's not in our triangle. So we have two options. We can either remember something fancy from geometry, which tells us that if I have two parallel lines and I have a transverse, then the interior opposite angles are the same. So I know this is 58 degrees. But that requires some remembering, and you can see that. You can see that those are the same. An easier way to think about this is just to say, well, I know this is 90 degrees. I know this is a full 90 degrees. So this angle is 90 minus 58, aka 32 degrees. Yeah. Okay, so this angle is 32. And again, I got that. I'd said the whole thing right here would be 90. So if I take off the 58, I'm left with 32. All right, so I got my angle right here. I have the opposite side of the angle, the adjacent side of my angle. So tangent of 32 degrees equals x over 135. I chose tangent because tangent of an angle is equal to the opposite divided by the adjacent. I forgot to write that down. All right, so to get x alone, I need to multiply by 135. So my answer is whatever 135 times tangent of 32 is. I'll use this calculator just to show something different. Again, I want to check and make sure I'm in degree mode. So I check my mode. Degree is highlighted, so I'm good. 135 times tangent of 32 degrees. And I get 84.357. 84.357. I'm just going to round to 36. And then this was in meters. So I'm going to put my unit on there. So 36 meters. So we can't really always trust our diagram. It's a dangerous thing to do. But this makes sense based on what I can see. This does look like it's kind of to scale. This does look like about a 32 degree angle. So I do expect this side to be a little bit shorter than that one. All right, you have one more application question on this async work, which is a little tricky. So I'm going to help you kind of set up the problem. We do one in class that's kind of the same, but a little bit different. So I'm going to help you with the big pink problem. So you want to know how tall you want to know how tall big pink is the question. So you're standing here and you look up and you see your angle of elevation. So the angle above horizontal is 13 degrees. And then you back up 50 feet and you measure again. This time you see, oops, that your angle of elevation is 12 degrees. So this is not an easy problem. It doesn't feel like we have enough information, but actually you do. And I'm just going to kind of get you started here, help you set it up. We've got two angles here, and we know one distance. We know the distance between the first measurement and the second measurement is 50 feet. But we don't know how tall this is. We don't know how long that is, right? So what can we do? We can identify this unknown length as x, and this one's y, right, the horizontal and the vertical. And then we can say something like this. Okay, so I have tangent of 12 degrees. So looking at this guy back here, this 12th degree, is equal to opposite over adjacent, so y over x. Okay, tangent of 13 degrees is equal to y over, not x, because this 13-degree triangle doesn't include the whole x distance. It's x minus this 50 feet. So this is just to help you kind of get the problem set up. This is a tough problem, so do your best on it. It's going to be very difficult to figure it out, but we do have all the information we need here. We've got some value is equal to y divided by x. Some other value is equal to y divided by x minus 50. Essentially what we have is kind of a system of equations here. So see if you can solve this, see if you can figure out what to do next, and we'll talk about it in next class. Thanks, y'all. Have a good day.